So today we're talking about a couple of things. What we're talking about is our algebra properties, which are here, and we're also going to talk about simplifying roots. Okay, so first of all, let's go through our properties. So number one, if I take a look at A, it says state the property. It looks like the 3 has been distributed. Agree? So the property, it's got to be the distributive property, right? So we don't have to put distributive property of multiplication over addition, but if we just write distributive property, because it sure looks like that 3 times x and 3 times 3, right? There's my distributive property of multiplication over addition, okay? B, looks like the order changed, right? We went 3 plus 4, then 4 plus 3, and so if we're talking about order, that's got to be our commutative property, okay? So we're going to go commutative prop of addition, and go ahead and abbreviate, okay? You can abbreviate. Abbreviation's fine with me, okay? Real good hint with C is looks like the parentheses have been moved, right? We talked about that, where you could multiply 3 and 5, or you can multiply the 2 and the 3 first. So if the parentheses have shifted, then it's just a matter of where you multiply first. And so that looks like the associative property, right? You're just changing the parentheses around. So that's associative property of multiplication, right? Because we're multiplying. So we're just changing which 2 we multiply first, okay? D, 8 times 1. Hey, it kept its identity, didn't it? 8 times 1, it kept its identity. So we got this multiplicative identity property. So we're going to go multiplicative prop of identity. Does it seem pretty easy, you guys? Pretty easy. Okay. I'm adding it to its opposite. So it's, 8 and negative 8. So if I'm adding it to its opposite, like its inverse, so it's really an inverse property. So if I take a look at notes, where is it? It is that one right there. Adding it to its negative, right? So it's going to be the additive inverse property. So this is going to be our additive inverse prop of addition. Thumbs up so far. Am I okay? Yeah, Megan?
You have to say of addition at the end.
I would never mark it wrong. But technically, yes, because we're adding, we're not multiplying, right? So it would be good if you did. Okay, I wouldn't mark it wrong on a test because I'm nicer than that. But to be technical, yes, because we're adding, we're not multiplying, right? Okay. And then lastly, 2/3 and 3/2 gives me 1. The opposite 2/3 or its inverse is 3 over 2, right? It's multiplicative inverse. So if I take a look, it's this multiplicative inverse because it equals 1. So we're just going to go for multiplicative inverse of multiplication. Okay, how's that for abbreviating? Okay. How am I doing? Thumbs up? Let me see. Thumbs up? Anybody sideways? Sideways? Okay. Okay. Nobody down? Okay. All right. Example 2. Find the additive inverse and the multiplicative inverse. We want 2 things, okay, of negative 1/5. So let's first do the additive. I got negative 1/5, right? So if I take a look at my notes, I want the additive inverse, okay? Additive inverse. Okay, that's just to add it to its opposite, right? To make it equal 0. That's what my property says. Okay, so I'm going to go plus 1/5 because that's its opposite, and that would equal 0, okay? So that's my additive inverse. I'll circle that because that is my additive inverse, okay? Now I want the multiplicative inverse of negative 1 first. So I got negative 1/5. Look at my notes. Multiplicative inverse, okay? Multiplicative inverse, so here it is. So it's the opposite of it, right? So n and 1 over n. But this thing's already 1 over n, or so we'll flip it and make it, multiply it by, but we got to do the negative. Why does it have to be negative? Why does it have to be negative? Why do I have to make it negative 5? Negative 5. Why does it absolutely have to be negative 5? Why not just regular 5? Well, what's it supposed to equal? 1. If you don't have the negative there, it won't equal 1, will it? So it's reciprocal, and it does equal 1, so the multiplicative inverse is the negative 5 over 1. Okay, here comes the part that you will use for real. Okay, this stuff you're going to use in other math classes. So, simplify the square roots. Okay, so what we need to do is find two numbers. Okay, and one of the numbers we want to find has to be one of these perfect squares. Okay, so find two numbers. What times what makes 24? But one of the two numbers has to be one of these perfect squares. Okay, so what do you think? Harrison, what do you see?
6 times 4.
Okay, perfect. 6 times 4. Everybody agree? Now, I'm going to write it 4 times 6. Harrison, you're not wrong. I just like the 4 in the front because it's the one object squared. Okay? Did you guys hear what I said? Harrison said 6 times 4. He's totally right. 6 times 4. But I like it the other way around because I would like to be able to just cross out the 4 and bring out the 2. Okay? So I'm going to do that. Okay? The square root of 4 is 2, and the answer is just 2 squared roots of 6. Capiche? Okay. Example 4. 3 is a regular 3. So let's leave it as a regular 3. And then 18. What do you think? Yes.
2 times 9.
Nice. Yes, 2 times 9, but do you mind if I do it 9 times 2? Okay, I'm going to do 9 times 2. I just like the perfect square first. You're not wrong. Completely correct, okay? So I'm going to go square root of 9, square root of 2, okay? Now it's still square root of 9 square root of 2 because I haven't taken a square root. Okay? It's still square root of 9 square root of 2 because I have not taken a square root. So let's take a square root. Square root of 9 is 3. Right, now watch, don't get confused. Watch. This 3, which is this 3, is still this 3. This 3, which is this 3, is still this 3. Square root of 9 is another 3, right? And since they're next to each other, they're times, right? They're next to each other. And then square root of 2, okay? Now let's finish it up. 3 times 3 is 9, so I get 9 square roots of 2. Okay? Thumbs up? Anybody sideways? I want to see. Are you okay? Are you good? Okay, turn the page. Alright, it's a fraction. Well, with a fraction, let me break it up, because I think I see a 4. You guys see the 4? Let me rewrite it. When I do fractions, I'm going to go square root of 27 and the square root of 4. So to look at it as two different problems. I got a top part of a fraction I'll do something with, and the bottom part of a fraction. Now, of course, hopefully you see something really obvious. Nate, what do you see? What's the obvious that you see? What's the obvious that you see? How about the 4? Yeah, what about the 4? Can we take the square root of 4?
Yeah.
Yes, boom. Make that a 2. You okay with that? Okay, I mean, let's just go for the easy. Okay, let's go for the easy first. Okay, the easy was the square root of 4. It goes straight to a 2, okay? And what about 27? That's a bad number. That's an irrational number. What do you think? 4 times 8 is 28. Savannah. How about 9? Why is 9 and 3 such a good combination? Right, 9 times 3. And do you notice that I still wrote it as a square root because we haven't taken a square root. I still wrote it as square root of 9, square root of 3 because I have not taken a square root yet. But I'm going to now, right? Square root of 9 is 3, so this becomes a 3. So I got 3 square roots of 3 over 2. Okay? A little bit harder, but not too bad. So what I saw, let me go back. What I saw was a fraction, so I broke it up into a top square root and a bottom square root, right? Then I also, wait a minute, I can make this easy because I can take the square root of 4. I just did that right at the bat, okay? And then Savannah said, well, 27 is 9 and 3, right? And I took the square root of 9, became a 3, and I had it, okay? All right, example 6. There it is. There's example 6. Okay. Now, you can multiply square roots. Sometimes it's a good idea to do it. In fact, in this case, it's going to be a real good idea to go 6 times 3. It really is. Square root of 6 times square root of 3. I'm going to do that right off the bat. I'm going to get 2 square roots of 18, okay? Because there is no square root of 6 except for an irrational number. There is no square root of 3 except for an irrational number. But when I multiply, I get an 18, right? Now there's something good about the 18, right? So what do you see about the 18? What about the 18? Ben, what do you see about the 18?
You can multiply the square root of 9 and 2.
So Ben says, let's do the square root of 9, square root of 2, because that's a perfect square, right, Ben? Okay, and then we're going to be able to get something out, right? We're going to be able to take something out of the house. The square root of 9, make it a 3. So I get the 2 still. I'm not going to lose the 2. 2 is still there. Square root of 9 is 3. Since they're next to each other, we're multiplying, right? Times the square root of 2. 2 times 3 is 6. Square root of 2, okay? Thumbs up? Okay, so far so good. Okay, now, number 7 is super easy. Okay, super easy. Let me give you a little analogy on the board, okay? All right, real quick. You know this. You guys watching? 2x plus 3x. Can you add those? Yes. 2x plus 3y, okay? Real quick. Yes, you can add this 5x, right? Yes. Can you add 2x plus 3y? No. So you can add these because they're the same, right? So I can add these because they're the same. I've got 2 squares of 3 plus another 4 squares of 3. So the question is, how many square roots of 3 do we have? Put them together. We got 2 plus 4 gives me a total of, so if they're the same square roots, add them. We just get 6 square roots of 3. Okay? Easy, right? So if you add them, they must be the same square root. If they are not the same square root, you cannot add them. For example, on the side, little side note here, if I had the 2 square roots of 3 plus 3 square roots of 5, the answer is just 2 square roots of 3 plus 3 square roots of 5, because you cannot add them. If they're different roots, you cannot add them. You can't put them together. It's like x and y. Now let's look at example 8. So when I first look at example 8, I'm thinking I can't add them, right? Can't. But what if we break them down? What if we reduce them individually? And maybe by some miracle, we'll have something that can be added, okay? What do you think? Should we give it a try? All right, so let's take a look at the 18. Okay? I'm going to get 2. What do you think with 18? What's a good combination? 9 and 2. Square root of 9, square root of 2, minus 5. What's a good combination for 27? 9 times 3, okay? How am I doing? Okay, I can take the square root of 9, and that's 3, but the 2's right out in front, so the 2 times the 3 times the square root of 2, okay? I can take the square root of 9, that's a 3, we get the square root of 3, right? I can multiply and get a 6 square root of 2. I can multiply and get a 15 square root of 3. Now, can you subtract them? Doggone, I did all that work, I still can't subtract them, right? So that's it. I can't subtract them. That's what I get. I would have liked if I could have subtracted, but I can't, okay? Okay, example 9. Maybe I'll get lucky here, I don't know. Right now I can't do anything with it, okay? 150, boy, that's a big number. How many quarters do you have in your pocket? If I had 6 quarters in my pocket, how much money would I have? If I had 6 quarters, right here, I don't, because Landon probably took them. If I did, he'd probably find them, right? But if I had 6 quarters in my pocket, how much money would I have? Yeah. So what about 150? Can we reduce that? How's that for a big hint? Hint, hint, hint. What do you think? 150, what are we going to reduce 150 to? How about 25, square root of 25, and the square root of 6. Square root of 25 is 5, right? Minus 3 square root of 6, which gives me an answer of 2 square roots of 6. Those two we can subtract, okay? You guys all right with this? So, page 24. 1, 2, 3, 4, 5 problems. I know it's going to kill you, isn't it? But you can do it. I have faith in you. All right, so let's go ahead and